Now we're going to look at some dial-up protocols, different types of encapsulation protocols. We'll go into a little bit of data inspection and then look at some VPN technologies. So a dial-up protocol really is just an encapsulation protocol, and it's created so that digital data can go over a telecommunication line. And because a lot of our communications are going over lines that have already been set up for maybe the phone system, or they're specifically laid. So these are encapsulation protocols. Now SLIP was the first dial-up protocol. SLIP was developed when the internet was just mainly mainframes where the different military bases were connected. Some universities were actually connected for research. And what it means is that it's going to put a header and a trailer onto a frame that's going to go over the telecommunication line, because these telecommunication lines weren't developed specifically to move this type of information. So it's actually putting on the header and the trailer so it can be properly interpreted, like at a switching office, and go to the necessary destination. So SLIP is an older protocol. PPP is really its replacement. We don't really see SLIP around anymore. PPP is just the newer, better, stronger SLIP. They both work at the data link layer. And they're both doing the encapsulation of the header and trailer. But PPP has some benefits that we're going to look at over SLIP, but it also allows for authentication. It could do authentication through PAP, CHAP, or EAP, and we'll look at the different types. Now, just because it says a dial-up protocol, it doesn't mean it's just for dial-up. The PPP is used over any type of telecommunication line. So if it's a SONET ring, or using frame relay or L2TP that we'll talk about, it doesn't mean you're actually going through a modem. It's just an encapsulation protocol that goes over a telecommunication line. So you'll need to know that PPP works at the data link layer. And remember, we went through all of the layers. You have the application protocols that are going to put its information on. You'll go through the different layers, and each one of those protocols will put their own header and trailer information. And you get down to the data link, and it's the data link layer that knows that this is going over, a SONET, or it's going to go over UTP, or whatever it's going to go over. This is the one that's more intelligent, and so it will do the framing, which puts the header and trailer on, and then it goes to the physical, which is when it's actually turned into electricity. So why did we have to move from SLIP? Well, SLIP was slow. PPP actually does compression that allows for faster data throughput. It uses sequencing, packet sequencing. It doesn't require an IP address to actually start the connection. And what we mean by that is your ISP, when you connect to the internet, your ISP is going to assign your system an IP address, one of its IP address in a range that it's purchased. But if you think about all of the customers of that ISP, if all of them had static IP addresses, then they'd have a whole bunch of IP addresses that they'd have to pay for. Instead, with PPP, basically I can communicate to my ISP. I could start my authentication process before it actually assigns an IP address to me. So it's allowed to save its IP addresses and use them. Not every single customer has to have an IP address. In SLIP, you had to have an IP address to actually start the connection. With PPP, you start setting up the PPP connection, and then you're assigned your IP address. And PPP has more authentication versus SLIP, which we're going to look at those different types of authentication protocols.